So good luck to everybody who is attempting to solve this here on this episode of Model Monday Live. Here we are on Model Monday Live. It is June 9th, 2025. It's so great to see everybody here in the chat on this episode of Model Monday Live. And we are now in the second half of the show. And in this second half of the show, I'm going to challenge all of you to solve a model that we just released just a few moments ago. We just released it here. And we do this every week on this live stream, Model Monday Live. So if you are watching a recording of this and you want to join us next week, just tune into the live stream, 1 p.m. East Coast. You can join us here on Model Monday Live. And on the second half of the show, we challenge the users to do a live solve right along with me. And so you're going to notice that over in the chat, over on the left, you're going to see the users maybe commenting a little bit on this challenge. But the challenge is found here at tootalltoby.com. You say, click here to get started. You sign up for a free account. And then you're going to see that we have this featured challenge practice models up here at the top of the screen. And the brand new featured challenge practice model that we just released is this one here, 250602. So today I'm going to solve this using Onshape. So I'm going to get my seat of Onshape ready here. I'm going to click here to practice. We can see that currently no one has solved this model. So we're going to try to be the first to complete this practice model. So here we go. This challenge begins in 3, 2, 1, go. So the question here is, what is the mass of this model? And we can see that the clock is counting down, and we're going to enter that mass right down here. We're going to also notice that this challenge has a title block with a material and a material density. And one of the things that I really like about the Practice Models app is that we can open in new window, and then we can just take this window and move this window around to make it a little bit easier to have our CAD system on one screen and the challenge here on another screen. So we can see here that this challenge is a machined part. We can see here that this challenge is not symmetric. There's no centerline symmetry. So when it comes to the location of the origin on a non-symmetric part, it becomes a little bit more arbitrary. Usually what you'll do is if you know the part is going to be machined, you'll just end up putting the origin on one of the corners because that'll make it easier for the machinist to kind of zero out their machine when they're seeing this thing. So maybe we'll put the origin here, or maybe we'll put the origin down here. I tend to kind of work from the upper left and kind of work my way down. So I'll probably end up putting the origin here on this corner. And so once you decide on where the origin is going to be, the next thing you want to decide is how your sketches are going to be constructed for this model. So I think that for me, what I'm going to do is I'm going to create a sketch that looks a little something like this. Whoops, kind of coming down at an angle here at 4 degrees. I think I'll probably create a sketch like that, and that'll be my first sketch. And then I'll take that sketch and I'll extrude that out to 60. And then I'll create a second sketch here that looks a little something like this. Maybe I'll include the hole in that second sketch, maybe not. And then I'll extrude that out to this depth here of 40 millimeters. And that's going to give me kind of the foundation of this design. The rest of the design is really just going to be some cut extrudes. So not too difficult of a model. It's tier 4. It's really right between a tier 3 and a tier 4 model. It's right on the cusp there of those two. So let's get into it here in Onshape and see how we would solve this thing. Again, all of our users here on Model Monday Live are trying to solve this at the same time. So it'll be really interesting to see if I can get this answer in before some of them. So we're going to go here to our keyboard cam. We're here in Onshape, and let's get this party started. We're going to say create a document. I'm going to call this 25-06-02, and I'll call it 4 degree block. And this is going to be a public document, so if you ever have access to Onshape, either the free version or the paid version of Onshape, you could always look this up in the public space and see what my feature tree looks like. So I'm just going to come up here real quick and go to my workspace units here from this hamburger menu and just make sure that I'm working in millimeters and grams. Very important to work in the correct units. And then I'm going to follow my game plan. Front plane, S key, begin a sketch, N key to get normal 2, S key to begin a line, and I'll single click here on the origin, move straight down, and then I will single click in the background, let go of my mouse, and type in a distance 20. Then I'm going to move my mouse down here kind of at an angle of 4 degrees. I'm not sure exactly what it is. Single click. I'm going to move my mouse up here until I'm horizontal to the origin, single click, and then I'm going to move back to the origin and single click again. And then after I single click there, I'm going to let go of my mouse and I'm going to type in 165 for the width of that block. Now, originally I said I would make that second sketch as a separate independent sketch, but really in Onshape, there's no need to do that. I could just create second sketch right here. So I could create a second sketch here. I could create a line that comes up like so. I could type in the dimension for that line, 90, enter. Could create a line that comes over this way, single click, type in the dimension, 106, enter, and create a line that comes down and just kind of include that geometry in this first sketch. And really, I could also create the geometry for the circle here in this first sketch. So create this circle here that has a bore of 57, and then I can create some dimensions to that circle. It doesn't mean I have to extrude all of these at the same time, but it might be smart to include this geometry here in this first sketch. So I'll create this here at a distance of 42. Now, the thing is, this dimension here, this 53 dimension, I think that it stands to reason that that's probably going to be centered on this block. So if I was a designer, I would probably want to include that dimension, include that 53 dimension in the design, but I'd probably always want it to be centered on that 106. So maybe what I could do here is I could right click on that 53 and then say change to a driven dimension. So you can see here now I can move this all around, and then I could just draw in a construction line or even a solid line here that goes from the midpoint to this point here, and then make that line vertical. So there's a little trick you can do there in Onshape. You can right click on a dimension and say change to a driven dimension. And that way, if this dimension here were to change to 120, that dimension is going to update, but it's a driven dimension because of that vertical relationship to the origin. So just a little extra trick there if you're following this Onshape tutorial. All right, final thing we need to do here with this sketch is just add in that 4 dimension. You'll notice up here that the sketch is currently under-defined, meaning it's got this little minus sign here, so something in the sketch is still loose. And we can see here that that loose thing is the angle for that 4 degrees. So S key dimension, create a dimension that goes from this line to this line, and that dimension is going to be 4 degrees. And so now that little minus sign goes away. There we go, no more minus sign. That's what we want to see. We always want to see a fully constrained sketch, a fully defined sketch in our tree. That means our sketch is going to be predictable, and that's definitely something you should always be shooting for. Get rid of those little minuses. So now I'm going to press S key extrude, and currently you can see that the whole thing is extruding. Well, if I press the space bar on my keyboard, you can see that that clears that whole extrusion. And so now I can click on this face here, and I can choose to extrude that out to a depth of 60 millimeters. So boom, there we go. That gives us that extrusion there. And then I'm going to hit the green check mark. Now I could extrude it out this way to make the next step a little bit easier, but this is a tutorial, so I am going to intentionally extrude it out this way. And what I'm referring to here is now my sketch. So here I'm going to go into the tree. I'm going to click on the little eyeball here for sketch 1. Now my sketch is not on the correct face because I need that sketch to be out here on this face. Well, what I can do is I can choose S key extrude. I can choose this region here to extrude, and then for the starting offset, I can choose entity, and then I can just choose this face here. So basically what I'm doing is I'm saying take that sketch, project it onto that front face of the model, starting offset this face up here, and now you can see that I can do my extrusion. Let's do a reverse direction, and that extrusion is going to go to a depth here of 40, enter, and that's going to be an add in Onshape. We're going to add that geometry to the block there in Onshape on that front face. So now I can hit the green check mark, and boom, there we go. Now, if I wanted to separate those features, like maybe this one would be the, I'll call this one 4 degree base, and then this one is going to be the upper block. So I'm using Shift N to do that rename. Sometimes what I like to do is have each feature be explicit. So I could double click here on this upper block, and then I could choose to also extrude that circular region. So there's that upper block. And then I could once again do an extrusion. So here I could just go S key extrude, and then I could pick this circular region, and I could say I want that to be a remove through all, and then I'll reverse the direction of that, reverse direction, and there we go. And the reason you might do that would be for configurations. So now if I go over to the tree here and I do Shift N, I could have a configuration where the bore in upper block is turned on, meaning unsuppressed, and then I could have a different configuration where that is suppressed. So you can turn features on and off temporarily in different configurations, and that's usually the motivation for creating an explicit feature rather than just including everything in one single feature. So just something to think about as you're getting deeper and deeper into the world of 3D CAD. So now I can hide this sketch 1. I don't need that sketch 1 anymore. And now I'm ready just to go through and add in those final cuts. So I'll start here on this face, S key, begin a sketch, N key to get normal 2, S key, I'll create a line here, and then maybe I'll do an S key and drop a point here at the center of that line, because I want to define the location of that slot to the center of the slot at a distance of 25, and then the location of that slot from this edge of the part to the slot at 30 millimeters. And then I can hit escape, I can click on that line, and then I can choose this flyout menu for offset, and I can choose slot. So once we choose that option for offset slot, there you see we're able to take that geometry and turn it into a slot. I'm going to double click here on this diameter 20 and change that to 25 and enter. And if you like the slot command in Onshape, be sure to hit the like button on this video. And so now the final thing I need to do is just define the length of that slot. So S key dimension, and that's going to go from this arc to this arc. That gives me the tangent in Onshape, and that is going to be 30 millimeters. And so S key, extrude, remove, through all, enter, enter or green check mark. And then I'm going to rename that one. So Shift N, that'll be called slot through. And then finally, these holes up top here, or almost finally, S key, begin a sketch, N key to get normal 2, S key. Here what we could do is we could use the little trick of creating lines instead of dimensions. So I could begin a line command here, single click, move my mouse up in this direction, single click, and then type in the distance here of 16, enter, move my mouse over in this direction, single click, type in the distance of 21, enter, move my mouse over in this direction, single click, type in the distance here of 64 for the hole spacing. So instead of going through and adding dimensions, you could do it with a series of lines and then S key circle, and we could single click on this point here, drop in a circle, and then single click on this point here, drop in a circle, and type in a dimension of 14, enter, and then hit escape, pick the one circle, pick the other circle, and then press E on your keyboard for equal. And boom, there you go, you've got those 2 circles. And what you learn when you practice a lot, when you use the Practice Models app, or you just do a lot of practice, is you learn that you can then do S key extrude, and then you could say remove and through all, and you see the Onshape is just ignoring those lines. So we're getting exactly what we want. Now, how do we know that we're getting exactly what we want? We just practice. Just practice, and then you realize, hey, Onshape doesn't even care that there's a line ripping through this sketch here. It just kind of takes the circles and gives me exactly what I want. So it's perfect. It's a perfect application for those lines as dimensions. So we hit the green check mark, and there we go. We've got those holes running through that part. And so we could call this one 2 mounting holes, something like that, or just mounting holes. Shift N to rename there in the tree. Always good to rename your features. And then finally, we're going to be adding in some fillets here. So this is a little trick that I did with the fillets that's kind of interesting. I could go in here to do my fillets, and I could do S key fillet, and then I can right click on this edge here, and from the right click, I could choose select, and then select parallel edges. Now, what's interesting here is that it goes around and it gets most of the edges that I want, but it also gets these edges down here inside of the slot. Now, the question is, does that matter? Does it matter that I get those edges? So let's find out here. So let's change our radius for those fillets. So it looks like that radius is radius 12, 5 places. So radius 12 here, and then 5 places. So I don't need this edge here. That edge can be cut straight, and I don't need this edge here. That edge can be cut straight as well. But you can see that I have an additional 4 edges selected here. So there's a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges that are selected because it's getting these vertical edges here as well. But if I hit the green check mark, I still get what I want. I mean, these edges are vertical, but they're already tangent to another face. So does it really matter that those edges are part of that fillet? I don't know. I don't think it really does. I could see it maybe coming up later. It's a little bit sloppy for me anyway. It's a little bit sloppy. I don't really like having those extra edges on there. So if it was me, I would probably go through and actually get rid of those, hit the X here and get rid of those 4 so that I only have those 5 edges. It also makes it a little easier to count when there's only the 5 in there. But I just thought that was interesting as I was going through. And it's a good reminder that when you jump into the fillet command, there's a multi-selection tool that is available. It's pretty useful. So S key fillet, right click here, and then you could say select, and then you could say parallel edges. There's also an entire section here for create selections where you can really get into some deep tools that you can use to define what your selectioning tools are. So there are some pretty cool additional capabilities here when you're doing selections in Onshape, but we'll save that for another tips and tricks video. So that gives me those 12 millimeter fillets, and then the only thing I need is for the toolpath. You know, when you're machining a part like this, you're gonna have some type of a tool that's gonna come in either from this side or from the top, and that tool is it's probably not gonna have a straight bottom. It's probably gonna be a rounded end mill that you're gonna end up with there. So that rounded end mill is why we end up with those radii in the corner there. You're gonna end up with a radius here from that rounded end mill. So if we go in here and we go to our fillet command, S key fillet, we're going to emulate that just by ripping a fillet here around this bottom edge of the part. So that fillet is going to have a radius of 6, enter, and there we go. We can press the letter P to hide our planes. So now we've got our planes hidden. We can do what's called the final spin, kind of look at this thing from the top and from the bottom and kind of all over here looking at this thing. And then finally, we can maybe change the color of some of these things. So we could go down here to the name of the part. We could right click and we could say, first of all, we could say rename. It's going to make it useful when you're going to add that part into an assembly studio, or an assembly mode. So we're going to rename that to 4-degree block. Or angled block might be a good name for that too, in case the 4 degrees changes. And then we're gonna go to that part name again, right click, we could say edit appearance. And if we say edit appearance here, we could change this to kind of match the appearance of the part in the from the customer. Customers always like it when you do this, when you try to match the appearance to what they gave you for their physical parts. And then finally, we can right click on the name of that part again. And from the right click here, we could say assign material. And this material is going to come from the Too Tall Toby library of materials. So we do have a video on this. I'll include a link to that video down in the description. But this material is going to be 1060 aluminum alloy, and we hit the green check mark. And then down here in the corner, we've got the option to measure the mass of this part in Onshape. So we're going to measure the mass of this part in Onshape. We're going to click on this part here, 1291.5 grams, 1291.5. If you click on it, you see you can expand it out and even get more details about it. But 1291.5, let's see if that works for our challenge here. So we go back into the challenge here, and once we go back into the challenge, we're going to type in 1291.5 and enter. And oh yeah, we did it. We got it correct. Anytime you see that purple box that shows up, that's always a good sign. That means that you did it correct. So congratulations to us. We did it. And the correct answer, 1291.5, was within tolerance. We did it in 15 minutes and 27 seconds. So what do you think? Did anybody out there watching in the chat do it any faster? Let's submit this so that we get 1 point on the community scoreboard. And let's go down and take a look. Oh, look at this. 8 people have completed this challenge. Very nice. 8 people have completed this challenge. So we go down here to our first 42 board, and we can see here that our first person to finish this challenge was none other than CSWE Victor. Victor K, the world champion of 3D CAD speed modeling, coming in today with a clean sweep on the Model Monday Live points. He does earn the point here for finishing this model in a mere 4 minutes and 32 seconds using Onshape. Wow, Victor K, what is the secret? That is fast. Good job, my friend. And we see Gray here came in using SolidWorks, 5 minutes and 47 seconds. Very nice. And Rambro's Workshop coming in here using Fusion 360 from India, was able to finish this challenge in 6 minutes and 40 seconds from the time it was released. We have P. Kieran's coming in here, 8 minutes and 38 seconds. Well done. And we see here Aaron C., 8 minutes and 54 seconds. Now, this isn't necessarily the time that it took them to finish it. This is just the time from when the model was released. We released the model here at about 1:30 p.m. And this is when these runners finished that model. And of course, we see also down here, we've got the CAD Queen. I think that's Kate, right? The CAD Queen here, Leopold 340. Finished it in 9 minutes and 4 seconds. Very nicely done. And Undefined, using Onshape, very nicely done. And Undefined Explode here, 12 minutes, 54 seconds. Very nice. And then Nikola Tesla, bringing up the rear. That's my account, 17 minutes and 42 seconds. So that is the first 42 for that challenge. You'll notice here that the top 100 might reflect slightly different times because the top 100 is based on when you click the start button to when you click the finish button. And that time can be improved. You know, Gray could come back in here now and try to run the model again. And then Gray could actually get a faster time than Victor K. So he would move up on the top 100 board. But the first 42 is immutable. Once you solve it from the time it's released, that's it. So Victor K will always be at the top of that first 42 leaderboard. So congratulations to Victor K. Well done, my friend. And the question here that everybody's wondering in the chat is, what do you need to do to beat Aaron C? We see that Aaron C is down here in 5th. Victor K was in 1st. What do we need to do here to beat Aaron C in these challenges? And the answer in the chat is the secret is bribing Aaron C's coworkers to distract him. Yes, that is an excellent secret there to take those points away from Aaron C. But congratulations to everyone. Of course, now that I've got the solve complete here, I can go into data and analytics, and then I can go down here into my tutorials, and I can post a tutorial. This is something that's a little bit newer here in the Practice Models app, but I can post a tutorial here. I can specify what CAD system I'm using, what language I'm using, and then I can